Now you can put a face to the voice, right? Yes. So I am Albert Osei once again, and I am a software engineer with Enyata, and I am based in Ghana. So I'm with the Ghanaian branch here. I am basically part of the backend development team here in Ghana. We are a team of about close to 15 to 20 people. We we've been building some products so far, and it's been interesting. Today we have a very interesting topic on our hand, and today is going to be a sort of, let's just say, sequel one. So I had to divide it into sequels because you cannot exhaust functional programming to its depth, to its core, right? We would have to break it into modules and see how best we can understand it very well. I'm going to share my screen so that we take it away. All right. Do let me know when you are able to see my screen from here. Okay. All right. Please give me a moment to share my screen right now. Okay. All right. I hope you can see my screen. Start
Yeah, we can
sharing
see
it
your
now.
screen.
Awesome. Thank you. Functional programming. To begin with, we would like to ask ourselves what is functional programming, right? And it has a lot of meaning, but some of the I kind of deduce this meaning with understanding from reading some sources as well. So functional programming basically refers to programming with functions. If we are very conversant with programming in a whole, we are aware of different paradigms of programming. Programming in itself basically refers to tackling or the ability or the act of tackling or facing challenges with problem or facing problems with the aim of solving them with code, basically. And there are different paradigms when it comes to this. What this basically means is that different people have different sets of approaches they will use in solving a problem. As there is a popular saying that there are many ways to kill a cat, if I'm right. There are several ways you can use to kill a cat. So that basic or that analogy being drawn here, we kind of grasp the understanding why programmers or software developers will adopt certain or different paradigms in solving problems with code. And these paradigms of programming are being used on particular problems, types of problems, right? So if I am solving a problem with the aim of a problem that is more related to real world problems, I want to use more of object-oriented programming. If I'm solving problems where I would like to adopt abstraction, I'm going to break them down as I go on with this. Abstraction, I'm going to adopt more functional programming, right? there are different paradigms of programming. You have dynamic programming and whatnot. But today we'd like to focus on functional programming. Our first task today will be looking at what functional programming seeks to, the kind of problems functional programming seeks to solve, and what different ways can we use to apply, or how can we apply it in solving problems or when we are programming. As we can see on the screen, that functional programming basically refers to programming with functions. And a function, what then is a function? A function primarily takes in an input and then produces an output. That is basically a function. So you can think of it as a system which takes in an input, like you feeding it something, and you expecting it to produce something at the end. Now let's move on. What problems, or what problem do functional programming seek to solve? So functional programming basically seeks to solve the problem of modularity and compositionality. When I say modularity, as I progress on, I will digest more onto it. But what I do mean by modularity is the ability to have my, or what I do mean by compositionality is the ability to have my program or my work more composite enough. A more modular software, functional programming leads to more modular software. And a modular software basically refers to you being able to break down your code into smaller chunks and being able to reuse it later on. I will explain more on modularity as I have a screen or a slide dedicated more to that. Now, the superpower of functions is that they compose. That is one key thing about functions. So as programmers, we adopt functional programming because we have the ability to use it in different parts of our work. Since a function basically takes in an input and then an output, it serves as the purpose, or it serves as a purpose where we can reuse it in different aspects of our work. And I'm going to explain much more into it. So this is kind of like the first gist that you are going to get into that. The next point is that functional programming seeks to improve the overall architectural design of an application. So when I have an application and I want to design it in a way that I can use it in different parts of my work, I want to make sure that I adopt functional programming because one, they are modular, and two, they are composite enough. We can make it compositional enough where we can reuse it in other parts of our work as well. Now let's dive deep into modularity. So all the problems I want to seek to draw your attention on why programmers or why software developers, we will seek to use the functional programming paradigm to solve problems, right? And if you don't get anything from here at all, one thing that you can get is that one is modular. Functional programming seeks to solve problems with modularity. That is, you can take it apart and then reassemble them in ways you never even anticipated them, right? And two is compositional. a property at the beginning, right? Or it's a property of a system to take in an expression or a value at the beginning, and it's multiplied by itself or it's being evaluated. When I mean it's being evaluated, that means computations are worked upon it. When after that process or after that computation I work upon it, the result that I'm getting, I don't expect to get something different from what I started with at the beginning. That is idempotency. And it's the same thing as we make reference to it in mathematics and also in some aspects of programming. And it's the same thing as referential transparency in functional programming, and also the same as substitution model. Now, to quickly move on, what are side effects and pure functions? So I know you guys will have a lot of questions, right? And I want to quickly finish this, and so that we make it more interactive, right? I think that will make it or make you understand it more. Now, what are side effects, right? Now, a side effect is a change of a system, a system state, or observable interaction with the outside world that occurs during the calculation of a result. So let's script this meaning of it. It doesn't help us here in any way. Now let's try to break it down. Now, as I was saying, when I like using a cornmeal, I don't know why, that example. So you have that cornmeal example, you place in the maize fruit, right? It's supposed to bring out the paste of the maize. Now, the moment it produces something else like tomato paste, no, that is a side effect, right? We are expecting to receive what you input in is what you should get out. The moment you get something else from the first thing you inputted in, then we refer to that as a side effect. Now, functional programming or functions basically seeks not to have side effects, right? It doesn't have side effects, unlike some certain paradigms of programming that you can have side effects that you can use side effects to execute certain programs, right? Now, for functions, you can't. Now, an example of, let's break it down to help us understand examples of side effects. Now, side effects, an example could be generating output beyond the return value. So I have a function, right? Let me show you guys a basic function, a code. So let's say this. I think. So I have this function, right? And this function is, the name of the function is display name, right? And what the function is returning is that it should return this.name. So for those of us who don't know, this is JavaScript. I'm using JavaScript as the kind of the primary language here to explain functional programming practically, right? So you have the function display name. It takes in any parameter. So at the value here that you want to put in can be any parameter at all. Now it should return this.name. It should return the name of, or it should return this. That's the execution call that you want the function to perform, right? Now, what I'm saying with side effects is that when the function takes in any input and it returns something else aside from what the function is initially doing, then that function is having a side effect. And that is what functions do not seek to do. So functional programming do not seek to have any side effect. It wouldn't have any side effect. It's going to input out, or it's going to take in the input that you are giving it and output exactly what you are expecting. It's not going to do any other thing else. Now, with other programming paradigms, when you call, or you are able to have side effects, right? You are able to read text from files. You are able to perhaps fetch an image from your hard disk, right? You are perhaps able to fetch a music video or a music file from your hard disk. But in functional programming, you have to, if you want to perform that kind of side effect, you would have to call the function will take in input and produce an output, and the output will call, or it will invoke a caller, which will instantiate that operation of causing that input, the input output operation, which is the file reading from your disk. Now, I want to quickly move on. So the function, an example of side effects that is a function, something generating output beyond the return value. And functional programming does not do that. It has no side effects. Now, an example is input I/O operations are input and output operations like file reading, just as I said, database access or HTTP request. Functions or functional programming will not have a direct connection with these things, but it would instead, if you want to perform these things with functions, you are going to have your output value or your output invoke a caller, which is going to instantiate these processes with the input-output operations. Now, I want to quickly move on so that we have the interactive sections. Now, pure functions, what are pure functions? Pure functions produce the same output for the same input, and there are no side effects. It's basically like functions, right? They produce the same outputs for the same input, just as I use the maze analogy, and I've used this for so many times here, just to help us understand. So for example, to make it more practical, it takes in, we have const greet takes is a function. We have a function which we are returning a string which is hello, right? This is a typical example of arrow functions, right? Is it in JavaScript is arrow function, and it's a form of writing, or it's a type of writing your functions in JavaScript. Now the function takes in, or the function is basically to return hello. So function returning constant value is going to return a constant value, which is hello. This type of function is, or this is what we refer to as a pure function. It produces the same output for the same inputs, and there are no side effects. This one is not going to return anything else aside from the hello, right? This function is not going to return anything else aside from hello. Now, the converse of a pure function should use you guys to is the basic, or the reason why we use, or programmers will use functional programming, will adopt the functional programming paradigm. Now I'm going to do a few practical sessions, just one practical session with immediately invoked function expressions in JavaScript, and then we are going to have an interactive section where you are going to ask questions, anything, ask me anything that you want to know, or anything that you want to also contribute to today's session. Now, today's purpose was to introduce functional programming to you. Why at all are we adopting functional programming as a paradigm as software developers? And those are the reasons why the reasons I've given earlier explain it much more further. That functional programming seeks, or its superpower is that it's compositional, right? It can take in an input type A and produces output type B, and you can use that output as an input of another function. That is very much useful, very much reusable, and it has so many uses, or it helps in so many ways when we are coding, when you are programming. And two, it is modular, so the ability to break down your functions and then reassemble them in ways you never even anticipated them before, right? You're able to break down the functions, use them in other parts as a function as a part to another function, and perform even bigger or larger complex computations. That is one use, or one help, or that one help functional programming seeks to give us when we are programming. Now I'm bringing my section to an end practically with the immediately invoked function expression. So we're going to have a very brief practical section. and then we have an interactive session. I want you guys to talk. I kind of talk a lot and say a lot of technical things, but I'm hoping I was able to break it down so that most of you can understand it. And I apologize for the background noise a bit. I don't know why today I'm having these noises. Now, immediately invoked function expressions is a type of writing your functions in JavaScript. So I wanted to use this as an example so that we have more practical session. Now let's take const b. So this in JavaScript, const means it's a constant, and the b is the variable, which is a constant, right? So it's constant. That means it doesn't change. The value doesn't change. If you want to, then you can call it only once. You can't be making reference to it in other places in multiple times, right? So it has a function. It takes in a function which is add two numbers. It takes in the number 1 and then number 2, right? And what the function seeks to do is that it should subtract number 1. It should subtract number 2 from number 1. That is basically what the function seeks to do. And then it should return that operation, which is, I called it sum, right? Now, in immediately invoked function expressions, ideally, when you declare a function, you are supposed to invoke that function. Basically, determine invocation as simply your mother gives you name, right? Your mother gives you a name, and your mother wants you to do something. Your mother gives birth to you. He gives a name to you, right? And when your mother wants to call you to do something, he has to call you by that name. So your mother can't telepathically look you right into your eye and tell you what to do, right? Or tell you to come here. She has to call your name so that you come. And then if there's any task that your mother wants you to do, she tells you to do. That is basically what we refer to as invoking a function in JavaScript, right? And in immediately invoked functions, you don't have to, this is how you are going to call the function. You just give it the arguments. Now the 10 and the 8 are referred to as arguments, right? And then number 1, number 2 are the parameters. As you can see, Replit gives you that parameters. Now the 10 and the 8 are the arguments. So the values that I want to substitute in place of the parameters, number 1, number 2, to return this operation or to give me this operation, which is subtracting number 2 from number 1. So in this case, it's going to subtract number 8 from 10, and it's going to give me a value. So if I run this, it's going to give me 8 subtracted from 10 is going to give me 2. That's what I see in my console here, right? And that is what functions, or that this a form of writing your functions in JavaScript, which we call the immediately invoked function expressions, right? And you could see that the function has no side effects. That means it's taking in the input values and it's going to produce the outputs, which I'm telling it that it should subtract number 2 from number 1, right? And it's going to bring out just the 2 for me. It's not going to do anything else, right? At this part, if I want the function to perform anything else aside from this, I would have to write another caller within this function, which would invoke an operation to do something else that we call as the side effect, right? So this is a short practical example of how functions operate today. So today's session is, I wanted to break it down because we cannot exhaust it completely, and so that we can have more time to be interactive and then talk about this. I like discussing programming stuff, new things that I learned. So we can talk about it now. If you have any questions, anything that you guys find it interesting on the slide that you'd like us to discuss it now, I am open, and yeah, we can talk about it from here. All right. So I am done, and I would like to open the session for any questions. Please ask questions if you will.
Um, the question I want to ask is please, because I didn't really follow up, which I know that it's going to be a pre-recorded session. But concerning this his own lecture that we are having, is it the same with the one you told us about? So because I don't have a background knowledge of it, but from what I'm hearing, I'm also interested. So let me know if it's the same thing with that one you spoke of, so that I will know how to go about it.
All right.
That's what I'm talking about. But I don't know the one he's talking about. Oh, okay. But sorry, don't be offended. I have one more question I want to ask. This you mentioned something about um transparency. I didn't get that very very well. Is it functional transparency? I be what? I didn't get that part very well.
Right. So what I said was that I was referring to referential transparency. So basically, what referential transparency means, have functional programming. What I say is that functional programming is referentially transparent. So if I have an input, let's say I have input A, right, and it should produce. If I have like five, okay, let me make it more practical. Now I have mathematics, right? 5 plus 7, right? I have 5 plus 7, and it is equal to 12, right? I can use that 5 plus 7 in place of, or I can use the value that results 12 in place of 5 plus 7 anywhere in my work or in my code, and I'm going to get the same thing, right? That is the meaning of referential transparency. So the moment an input, you have an input and then it produces an output, and you can use the output as a substitution of that input, then, and it works and it gives you the same results, then that means it's that system or that process or that property is referentially transparent. It's the same thing as substitution model, right? So 5 plus 7 is equal to 12. Wherever in my work I can use 12 in place of 5 plus 7, and I can I can continue solving my work, right, mathematically. Now, the reason why we use this is functional programming helps us. Oh, okay. So modularity is different, Chisom. So modularity is the fact that you are able to reassemble or break down your work into smaller parts and then use it or reassemble it in ways that you never anticipated it from the beginning. That is what we refer to as modularity. Right? So I can use my work in different areas. So if I have a property like, let's say, type input A, which a function that takes input A and produces output B, I can use that output and use it in another part or in another function, which is going to form as an input to that other function, and still is going to work. We will be able to work with it. That is how, or that's what we mean by our function being modular, right? We can use it in different ways. We can use it, break it down into smaller pieces. We can have so many functions, and we can reuse it in different parts of our work. That is how functional programming is one superpower of functional programming. The fact that you can break your code, your work into smaller chunks and reuse it in different aspects of your work. That is what we refer to as modularity. So as I said, referential transparency, on the other hand, is the substitution model. So you can substitute maybe 7 plus 5 is equal to 12. I can bring 12 in as a substitute in place wherever I see 7 plus 5 in my work, and it will work, right? Now, what are the importance of this? Why are we even saying all these big words and all these things? The reason is that when you are coding problems, or when you are attempting to solve problems, you have to adopt some abstractions. So if we can go back to our junior high school and senior high school work, we have mathematics, right? Now, functional programming is a bit related to mathematics. Now, in mathematics, as I was using the 7 plus 5 as the substitution model and referential transparency, we are able to adopt abstractions. So abstractions are like we inviting some sort of things that are a little bit different from what happens in the real world, right? And it's in the aim of breaking down the problem into its smallest or simplest size, and then approaching or solving the problem from there, and then we'll build it from ground up. I don't know if you get it. So programmers basically solve problems, and we adopt certain thinking or certain ways of thinking to solve the problem, to solve these problems. And those are the things I call as referential transparency. Oh yes, yes, sure, Chisom. We are going to have some more sessions of this course, which this basically the sequel one, right? I am currently in the process of writing an article which explains more about functional programming, and it doesn't use JavaScript. It uses Scala. So Scala is one, or is another form, is another programming language which makes use of functional programming a lot, right? Also like Java and Haskell, right? So before I'm going to have, if we have another chance, we are going to have a sequel to, which we are going to continue. That is going to be more practical. I'm going to make sure I break them down into smaller problems, even make you guys follow practically whilst I'm going on working with you together, so that you guys will understand. But today, basically for you to adopt why programmers or as coders we use functional programming or adopt abstraction in our work, right? So that's the basic aim of this meeting. Please, is there any other question or contribution? I like talking. Please, although our time is up, we can talk more. Yeah. Anything else? Please, anything, we can talk.
Okay, I have a question.
Okay.
I would like to know, when do we use functional programming over class or object-oriented programming?
That output B can be used as an input to another function. Then we continue to work with it, and then it goes on and goes on. So if we want to perform some level of abstractions and having our work more modular and having our work more composite or compositional, that is when we adopt functional programming over object-oriented programming. Although object-oriented programming does have ways you can also perform abstractions with. Yeah. I don't know, is your question answered, Idion? Awesome, awesome, awesome. Yeah. All right.